Welcome Math 20-1 to 3.1 Part B, factoring general trinomials. Remember, if we expand two binomials, we get a trinomial. If we expand these two binomials, we get a more complex trinomial. 3x squared add 15x add 2x plus 10 gives us 3x squared plus 17x plus 10. We call this a complex trinomial because the coefficient in front of the x squared term is no longer 1. It's something other than 1. Note that the sum of 15x and 2x is the middle term 17x. Also note that the product of 15x and 2x is 30x squared. This is the same as 3x squared times 10, or the first times the last term of our trinomial. Therefore, to factor a complex trinomial, we're going to look for two numbers that have a product of 30 and a sum of 17. So the idea of sum product is going to happen again. That'll be the first step with factoring a complex trinomial as opposed to a simple trinomial. So we call this next method called the decomposition method. We're going to factor 3x squared minus 10x plus 8. We ask ourselves what two numbers add to the middle term, negative 10, multiply to that first times the last, 24. So the two numbers that add to negative 10 multiply to 24 are negative 4 and negative 6. So we're going to use these two numbers to decompose the middle term of this trinomial and make it into a four-term expression. So we're going to rewrite the middle term as negative 6x minus 4x instead of minus 10x. They're the same value, it's just another way of expressing it. So 3x squared minus 10x minus 8 plus 8 becomes 3x squared minus 6x minus 4x at 8. Again, negative 6x minus 4x, the same value of negative 10x, just looks a little different. We now factor by grouping. Common factor of the first two terms is a 3x. Divide that out, we're left with x minus 2. Common factor of the last two terms is a minus 4. Divide both terms by minus 4, you get x minus 2. This is really important that the common binomial factor is x minus 2. It must be the same. So these x minus 2's should be identical. If that's the case, we can factor out the x minus 2. We're left with 3x minus 4. Yeehaw. Method of decomposition. Works every single time. Here's some more examples. 6x squared plus x minus 15. Ask yourself what two numbers add to 1, multiply to negative 90. Well, those two numbers are positive 10 and negative 9. So we use those two numbers, positive 10 and negative 9, to decompose the middle term. And it doesn't matter which order we write these. All right? On the slide, I wrote it as 6x squared plus 10x minus 9x minus 15. But it could have been 6x squared minus 9x plus 10x. We'd still get a correct solution. So next step is to factor by grouping. The common factor of the first two terms is a 3x. We factor that, a 2x. We factor that out, we get 3x plus 5. The common factor of the last two terms is a minus 3. We factor out a negative 3 and we get a 3x plus 5, the exact same binomial. If that is the case, then we can factor out that binomial of 3x plus 5, and we're left with 2x minus 3. These are the factors of 6x squared plus x minus 15 using the method of decomposition. Works every time. If we want to see if we're correct, we could expand this out by foiling. Check it out and make sure that it does work. We get what we started with, 6x squared plus x minus 15. Let's try another one. What two numbers add to negative 5, multiply to negative 36? Well, those two numbers are positive 4 and negative 9. So we decompose the middle term using positive 4 and negative 9. Negative 9y plus 4y gives us minus 5y, so the value is the same, it just looks different. We now factor by grouping. Common factor there is a 3y. Divide both terms by 3y, we get 4y minus 3. Look at the last two terms. Those last two terms are the same as this bracket, 4y minus 3 already. So if I want to keep that the same, I'm just going to factor out a positive 1. If I divide both these terms by positive 1, I get 4y minus 3. Now my binomial is identical, the 4y minus 3. I factor that out. I'm left with 3y plus 1. Again, you could check by foiling, but we're pretty sure that's worked. Try number 3. Two numbers that add to 20, multiply to 36. Add to 20, multiply to 36. Those two numbers, they are 2 and 18. Decompose the middle term using 2 and 18. Again, it can be written in any order. So 3x squared plus 18x plus 2x add 12. Common factor of the first two terms is a 3x. Leaves us x plus 6. Common factor of the last two terms is a 2. That leaves us x plus 6. And we factor out the x plus 6. We're left with 3x plus 2. Beautiful. All right, we're going to now factor a complex trinomial using the inspection method. So the first thing we're going to do is list pairs of factors of the first and the last term. So all the factors of 6, 1 and 6, 2 times 3. All the factors of 3, 1 and 3. We're now going to do a cross multiplication of these things, these factors, and figure out which products will add to negative 11. So just watch. 1 times 1 and 6 times 3. Those two numbers, 1 and 18, add up to 19. That does not give us negative 11. So we're not going to use 1 and 1, 6 and 3. If I try 1 and 3, 6 and 1, we get 1 times 3, 6 times 1, 3 plus 6 doesn't add to 9. Sorry, it does add to 9, doesn't add to negative 11, so we're not going to use that one. We're down to one more possibility, using the 2's and 3's. So 3 times 3, 9, plus 2 times 1, 2. 9 plus 2 is 11. Excellent, that's what we want, a sum of 11. Sum's equal, so we're going to use the factors of 6 being 2 and 3, the factors of 3 being 1 and 3. We can now factor our complex trinomial. So place the terms in the brackets, keeping in mind FOIL. Remember to place in opposite brackets. We can't have the 3 in both brackets because there's not a common factor of 3, so we don't want those in the same bracket. So our factors should be 2x and 3x will multiply to 6x squared. There's our 2 and 3. 1 and 3 will multiply to 3. And if we have the 3's multiplied together, this is going to work. If we have the 2 times 1 multiplied together, there we have it. So if I expand that out, I will get my complex trinomial. Your choice if you want to use that method. The decomposition method always works. This method is a little more of a mental approach. That's why it's called the inspection method. Just by looking at this and doing some mental work, we can factor it. Most important thing is you can be able to factor one way or the other. All right. Let's do some more complex factoring with differences of squares. Very important note, x squared plus 25 cannot be factored. We cannot factor a sum of squares. We can only factor a difference of squares. Little hint, when the question asks you to factor completely, that usually means there's going to be more than one step. X to the fourth minus 16. This is an example of a difference of squares. X to the fourth has a perfect square root, 16 has a perfect square root. X squared is the square root of x to the fourth, 4 is the square root of 16. If I factor using a difference of squares like we did with the last set of notes, this should be x squared minus 4, x squared plus 4. Square root of x to the fourth, square root of 16. Conjugate binomials, one negative, one positive. But we're not completely finished yet. Factor completely. This first factor, x squared minus 4, is another difference of squares, so we can factor that again. So this becomes x plus 2, x minus 2. So we factor x squared minus 4 as x minus 2x plus 2. And don't forget we've got this factor of x squared plus 4 here, so we must include that. So x to the fourth minus 16, factored completely, has 3 factors that are binomials. We cannot factor a sum of squares, only a difference. So this one is now completely factored. If I look at x to the 8 minus 1, the square root of x to the 8 is x to the fourth. The square root of 1 is 1. I factor using conjugate binomials. This becomes x to the fourth minus 1, x to the fourth plus 1. Great. But we're not done, because x to the fourth minus 1 is a difference of squares. We can factor that. We cannot factor x to the fourth plus 1. We cannot factor a sum of squares. So let's factor x to the fourth minus 1. Square root of x to the fourth is x squared. Square root of 1 is 1. The factors here would be x minus 1, x plus 1. Don't forget, we've got x to the fourth plus 1 as a factor. We must include that. Now we're done. No, we're not. X squared minus 1 is also a difference of squares. So let's factor that as conjugate binomials. X plus 1, x minus 1. Very nice. And don't forget, you got the x squared plus 1 and the x to the fourth plus 1. So this difference of squares, we've got 4 binomials that we can factor it as. Now we're completely factored. X minus 1, we can't go any further. We're done with that one. X to the fourth minus 13x squared plus 36. This is a simple trinomial because the number in front of the highest degree term is a 1. So use our sum product method. What 2 numbers add to negative 13 multiply to positive 36? Well, those numbers are minus 9 and minus 4. So the factors here should be x squared minus 9 and x squared minus 4. Right? X squared times x squared will give us x to the fourth. If we expand this out, negative 4x squared minus 9x squared, that gives us minus 13x squared. So we must have x squareds in the front of the bracket if I have an x to the fourth as my leading term of this trinomial. But I'm not done factoring completely, because x squared minus 9 is a difference of squares. So I can factor that as x minus 3x plus 3. Oh, and x squared minus 4 is also a difference of squares. We factored that one earlier. That's x minus 2x plus 2. I have now completely factored this simple trinomial. All right. They get a little more difficult. We've got some with complex bases. So let's try some difference of squares with complex bases. X plus y all squared minus 16. Let's see how that turns out. Square root of x plus y all squared is x plus y. The square root of 16 is 4. So make your 2 sets of brackets. In the front of the first one, put the square root of x plus y all squared, which is x plus y. And the square root of 16 is 4. Second set of brackets, put x plus y, which is the square root of x plus y all squared. And the square root of 16 is 4. Then you make them conjugates, one negative, one positive. So now we're done factoring this complex based difference of squares, but we can expand and combine like terms if they occur here. So we're going to get rid of the brackets inside the brackets. So this becomes x plus y minus 4 and x plus y plus 4. And now we're done factoring. If we try one more, x plus 5 all squared minus 49. Again, make your 2 sets of brackets. The square root of x plus 5 all squared is x plus 5. The square root of 49 is 7. So we get x plus 5 minus 7, and we get x plus 5 plus 7. So again, the square roots become conjugate binomials. And now we can simplify inside the bracket. So we get x plus 5 minus 7 times x plus 5 plus 7, or in simplest terms, x minus 2 times x plus 12. All right. We're going to run out of time. I will have to stop this recording, and you guys will have to catch up. Look for the second screencast on complex bases, and we'll continue then.